not encouraging or advising anyone to modify their firearms. This is for entertainment and educational purposes only. This video contains clips and sections from 3 separate videos I've made about 1911 slide to frame fit in the past. Links to those videos are in the description. Those are the videos to watch if you want much more detail and you want to watch me struggle and make mistakes. So hopefully you can learn from those mistakes instead of making them yourself. I've compiled this video to put what I believe to be my best, most informative and accurate information about this subject in one place for my 1911 technical content playlist. I think a good place to start is to look at the original 1911 slide and frame designs and their dimensions. These dimensions all come from the M1911 book by Jerry Kuhnhausen. Here are the dimensions in question. They are given as upper and lower limits. This drawing is a bit busy. I'll simplify it. Let's take a look at the frame dimensions in question first. I will put the nominal values next to the given limits. I'm not going to read these out to you. Pause the video if you want a closer look. Here are the slide dimensions in question, isolated with their nominal values given. I've created a 3D model representation of the 1911 slide and frame rail areas to help us visualize this. The dimensions are all at their nominal values I just showed. I made them different colors for clarity. Sorry, I didn't pick the colors. The software did, and we got salmon and baby shit yellow. There are 2 rail interfaces, this one and this one, which I will refer to as upper and lower. Slide to frame clearance will have a vertical and horizontal component, and we are only going to consider these clearances in 2 dimensions for the time being. Initially, I've constrained the model to show even gaps on all sides of these lower rails. As far as I can tell, when talking about slide to frame clearance, it is given as total clearance, not clearance per side. In this case, the total clearance of the lower rail would be the sum of these 2 gaps in the vertical direction and these 2 in the horizontal direction. I'm focusing on the lower rail interface for a reason that I will explain shortly. At the nominal dimensions, this vertical gap is 2 thousandths, giving us a total clearance of 4 thousandths. This horizontal gap is 2.75 thousandths, giving us a total clearance of 5.5 thousandths. These nominal clearance values are in line with what is presented in the Kuhnhausen manual for an ordnance specification military 1911 pistol. Now I have constrained the slide and frame in a way that shows total clearance for clarity. The slide is pushed up and all the way to one side. The vertical clearance range at this lower rail is 1 to 7 thousandths. The vertical clearance range of this upper rail is 1 to 9 thousandths. The horizontal clearance range of the lower rail is 1 to 9 thousandths, and the horizontal clearance range of the upper rail is 2 to 11 thousandths. I played with the dimensions of the slide and frame rail models within their tolerance range, and I found that in an extreme case, the upper rail can dictate the slide to frame clearance in both the vertical and horizontal directions. However, the clearance ranges of the lower rail are narrower than the upper rail, so I'm under the impression that the lower rail interface is what is designed to dictate the fit and clearances of the slide and frame in the original design. I could be wrong, that's just my interpretation of these dimensions. That's why I was focusing on the lower rail just a moment ago. There's one measurement method described in Kuhnhausen where feeler gauges are used to measure the horizontal and vertical clearance. Putting a feeler gauge between the bottom of the slide and the top of the frame, as shown at position B, would push the slide up, and the clearance measured by the gauge could be dictated by the vertical clearance at the upper or lower rail. Putting modified feeler gauges in the 2 positions labeled A would show the minimum horizontal clearance, and presumably the minimum clearance could show up at the top or bottom rail interface. It seems to me when taking measurements of the rails and calculating clearances, the fit of the slide to frame would just be the minimum clearance measured in the horizontal or vertical direction, regardless of which rail interface that minimum clearance shows up at. There is a discussion that could be had about the tolerance stacking of all these dimensions in the horizontal and vertical directions. The vertical tolerance stack is the only one mentioned in the Kuhnhausen manual. It is not mentioned in relation to the clearances we are discussing, but the needed barrel length in the upper barrel lug engagement. And I think that's kind of outside the scope of this video. So what should these clearances be in the horizontal and vertical direction? Well, it depends. We have seen the range of clearances that would be deemed acceptable based on the original ordnance specification tolerances. I will be sharing some clearance ranges based on the application of the pistol given in the Kuhnhausen manual because they seem reasonable to me. Before that, I want to share this very important quote. There is no absolute slide frame rail slot clearance specification applicable to all categories of M1911 type pistols. These clearance ranges apply to both the horizontal and vertical directions. 4 to 6 thousandths for military and ordnance specification commercial 1911 pistols. Pistols for bullseye competition use might have clearances of 1/1000th of an inch or less. Pistols for other competition use may have clearances from 1 to 1.5 thousandths. Point number 4 seems a little vague to me. I will share my interpretation. If someone is assembling a 1911 pistol and they want the fit to be improved or better than the nominal clearance associated with ordnance specifications, a slide to frame rail clearance of 1.5 to 2 thousandths is suggested. When I hear the words carry pistol, I think of a concealed carry or duty pistol that someone is going to trust their life to. If that is the case, I would argue that this clearance range would also suffice for general use pistols. For the sake of simplicity, we have been considering these clearances in 2 dimensions and have made various other assumptions. To get an accurate idea of the clearances and how much they vary, measurements would need to be taken along the whole length of the slide rails on both sides of the slide and frame. Horizontal clearances and the position of the slide on the frame can affect firing pin placement on the primer, how cases interact with the slide and extractor as they're stripped out of the magazine, and where the ejector contacts the case rim as the slide moves rearward. In addition to all that, the vertical clearances can affect barrel lug engagement and lockup, the needed barrel length, disconnector function, and how the barrel lugs contact the vertical impact face in the barrel bed of the frame. There are likely some consequences of the slide to frame fit that I am also not aware of. It seems the best way to achieve an improved slide to frame fit for an Accurized 1911 is to fit and lap the slide in from zero clearance components. Starting with a slide and frame that have oversized rails, the location of interferences must be determined. Rail material must be removed until a near zero clearance or line-to-line fit is achieved. Kuhnhausen calls this a little bit tighter than a light drag fit. There will be minimal additional material removal with finer media until the slide and frame get to a light drag fit and then can be lapped in. After this process, the slide will move freely under its own weight, but there will be little or no perceptible play. The total horizontal and vertical clearance in this condition will be less than 1/1000th of an inch. Before taking any measurements, I made sure to thoroughly inspect and deburr the slide and frame rails. There really wasn't much to do. Frame rails, easy to measure with calipers. Measure in a few spots all along both rail sections. The frame slots, I put 90 thousandths gauge pins in the slots and measure across those gauge pins, and then I subtract 180 thousandths from that measurement, and that will give me my slot width. This is a groove micrometer. It has these little discs and it measures grooves inside and outside very accurately. You can get into places where you couldn't get otherwise. It measures 0 to 1 inch in 1/1000th of an inch increments. Measuring the slot height. So 15. Okay, so 50 plus 15 is 65. I'm going to measure more points along both rail sections, and since I'm measuring between here and here, I have to take into account the thickness of these two discs. They are 25 thousandths each, so I have to add 50 thousandths to that measurement, which gives me 115. Now I can use these to measure my rail height too. So that is 99 and a half. That one's closer to 100. And since I'm measuring between the two discs, I don't have to account for the thickness of the discs in this case. I'm going to measure up the slide in the same way. Groove mic to measure the slot and rail height, and then the inner rail width here I can get with my calipers. And then I will be sticking my gauge pins in this slot and measuring between them with my calipers in here. But in this case, I will have to add 180 thousandths to my measurement to get the inside slot width. I've made myself a couple of handy little visual data sheets. My vertical interference is coming from here and here. This is 3.5 thousandths wider than this, so there's going to be clearance on this upper rail and slot. So that means to get to my line-to-line fit, I need to take 3 thousandths off of this rail. Looking at my horizontal measurements, I have plenty of clearance between this slot and this rail. My interference shows up at this upper rail and slot. I have 3 to 4 thou of interference, or 1.5 to 2 thou per side. Looking at where to remove material, it's going to be easier to take it off here and here than from in here and in here. Similarly, it's going to be easier to remove material from this face, the bottom face of the slide rails, than trying to open this slot up. On page 100 in the M1911 Kuhnhausen manual, they point out the same areas to be adjusted when fitting a slide in a frame from 0 or near 0 clearances, adjustments at 1 and 2 for the vertical clearances, and at positions 3 for the horizontal clearances. As I'm taking any material off these rails, I want to make sure that they stay square and parallel. If I don't, we might have a weird taper or something like this on one of the rails, and then it's only going to be contacting at this little point, and it will wear off super quickly and your clearances will open back up. What we want is the rails to be square with each other to make sure we maximize bearing surface and minimize wear, and make sure those clearances that we've established stay that way for as long as possible. Let's consider this a top-down view of the rails, and similarly, if this rail surface isn't parallel to this rail surface and these rail surfaces aren't parallel to the slide slot, then you're going to have high spots somewhere that are going to wear off really quickly and your clearances are going to open back up. I have removed all the slide and frame rail material before by hand. This is difficult, very time consuming, and can result in unevenness across the rail surfaces. I would highly recommend machining most of the material off and leaving yourself about 1 thou to do by hand at each rail surface. I started with a 400 grit equivalent stone on the slide rails until I could get the slide on past the taper of the front rail section, so I knew that when it stopped again, my frame rails were interfering with the slide slot. I made a fixture or a jig for taking material off the frame rails. I started with some extruded aluminum angle stock, then machined one leg so it just replaces one vice jaw. I have a straight edge and a piece of sandpaper clamped in here. It's only sticking up high enough to contact the frame rails. Companies like Matrix Precision and Everglades Ammo sell jigs like this. At this point, I used 400 grit sandpaper in the jig I made to start removing frame rail material. I went back and forth between stoning the slide and removing frame rail material until I could get the slide all the way on to the front rail section. Then I switched to taking slide rail and frame material off with 600 grit. I went back and forth doing this until I could get the slide all the way on both rail sections. At this point, I switched to 1000 grit sandpaper for both. I kept working both rails very carefully and trying to fit the slide back on, but left the slurry created by the oil and the 1000 grit sandpaper on the rails, so it was lapping it in as I did this. And before long, the slide was fit how I wanted. I wiped off the slurry and oiled it up to see how it felt. Like glass, baby. Then I removed the little bit of material left by the spring plug tunnel that I didn't touch when I was taking my material off here. I did this with 600 grit sandpaper wrapped around my file. The last thing I'll do is go around and break any sharp edges, deburr stuff from the machining and fitting process, reestablish chamfers and radii as needed if they went away on the corners of these rails from the material removal. I'll also take some alcohol and a stiff bristle nylon brush and scrub down the rail surfaces really good to make sure I don't have any residual particles from that last lapping process with the 1000 grit sandpaper and oil left, in the frame rails somewhere.